Now we have seen three methods of allocation and we have seen the disadvantages of each one. So whenever there is a disadvantage in one method, we have moved on to the next method, right? So let's just revisit what were the disadvantages and why we moved on to the next levels. So first one is coming to the contiguous allocation, we had two problems. One was external fragmentation and the other problem was size declaration problem. I didn't tell you this earlier. So what is size declaration problem is, since you have to allocate this space contiguously, you should be able to predict the size of a file. So once you have declared the size of a file, you cannot grow beyond that. Now let us say you declared that I want 3 blocks for my file. Now if 3 blocks are allocated for your file, the next block will be allocated for some other file. Later if you want to increase the size of the file, there will not be contiguous block available, right? That is why you should be able to declare the size required for a file, and in most of the cases it might not be possible if the file is going to grow dynamically, right? So these two were the disadvantages coming to the contiguous allocation. Now these two problems are solved by linked allocation, as I told you. Now what was the problem in linked allocation? The direct direct access. Now this problem has been solved on the random access, right? So the random access was the problem in the linked allocation, and this has been solved by the FAT, isn't it? So FAT has solved the disadvantage of the linked allocation. The linked allocation was not able to support the random access or the direct access. That is why FAT was used, right? Now what was the problem of the FAT? In FAT, the size of the FAT table itself is going to be very big, that maintaining it in a main memory is going to consume lot of memory, right? For that reason, instead of going for FAT, we have one more solution which is called as indexed allocation. At any point in time, we will be trying to open some files. We will not try to open all the files, isn't it? Therefore, maintaining the information about all the files in the main memory at all the time is just memory wastage, isn't it? That is why what we try to do is, whatever file we need, only for that particular file we need to know where it is present, where all the blocks are present. So for that reason, we are going to maintain for every file one special block which is called as index block, and in some operating systems it is also called as inode, right? In Unix it is called inode. Now what is an inode or an index block is, for a particular file, it is just the name itself says the index. So what are all the physical blocks in which that particular file is present, right? For example, if you see this, let us say there is a file. Let us assume that the directory will be created like this. In the directory, it will maintain what is the file name. Let us say there is a file A, and now for every file name it will show what is the inode or the index node. Inode or the index node, right? Which means for file A, the index node is 10, right? Now by looking at this index node, you will find out what are all the blocks which are allocated to file A. For example, if you see this, let us say the index node of file A is 10. Now if you go to that particular block, in that block you can see that the block numbers are listed as 3, 5, 3, 4, 5, 8. It means that the blocks of the file are allocated in the physical blocks 3, 4, 5 and 8, right? So this is what is in the indexed allocation of the disk. So by having such a small implementation, you need not bring the entire FAT table into the main memory. You can just bring this one node, right, or one block. Now in case if the index itself is too big, if the file is too big, that the index itself is containing, it cannot fit in one block, then what to do about that we shall see in the next video. Got it? Okay.